Why, hello there! Today we are going to be talking about using the product rule to find the derivative of functions that require the use of the product rule. But Auducation narrator guy, when are we going to have to use the product rule, I hear you asking? Well, when your function is composed of the product of two other functions. Sometimes this is obvious, like in the second example that we have down below. Other times it is less obvious, like in the first example that we have down below. Here is how it works. If you let f of x and g of x be continuous and differentiable functions, and you let h of x be the function that is the product of those two functions, then the derivative of h of x, h prime, can be expressed as f of x times g prime plus g of x times f prime. Now I will admit that that looks a little bit complicated. We will have an easier time with the product rule if we express our f's and g's in terms of u's and v's respectively. Thinking in that way will give us a product rule that is u v prime plus v u prime. Therefore, all we have to do to use the product rule is define our u and v and then find their derivatives and then glue them together according to this rule. We can see how this works by taking a look at the example problems below. The first example we have here is f of x is equal to 2x times sine of x. It's easy to assume that f prime should equal 2 cosine of x. But if you're paying attention here, we can rewrite f of x as 2x times sine of x. This means if we want to find f prime, then we need to use the product rule. And we'll start by defining our u's and v's. First we'll write u. U is the first part of your function, so 2x this time. There. The product rule also needs u prime, so the derivative of 2x is just 2. Next, we write v. V is the second part of your equation. For us, that's sine of x. We write that down, and then we also need v prime. The derivative of sine is cosine of x. And then finally, we will combine these four terms by using the product rule format. F prime of x is going to equal u, that would be 2x, times the derivative of v cosine, so we'll put that right there. Then it's plus our v sine of x times u prime, that is 2. If we can, it's good to simplify. There's not much we can do here, so we will write 2x cosine of x, and then we'll just bring the 2 in front of sine. Therefore, f prime of x is equal to 2x cosine of x plus 2 sine of x. Very different from what we originally thought it was going to be. Now let's look at our next example. G of x is equal to 4 to the x times 7x squared minus 9. This time, our u is going to be 4 to the x. And with that, we can also get our next term, u prime, which is the derivative of that, 4 to the x times the natural log of 4. Don't forget, you're not often going to see regular exponentials, but they do show up. V this time is equal to 7x squared minus 9, which then means that v prime is equal to 14 times regular x. Now, we are going to combine these four terms according to the product rule format. This means that g prime of x is equal to u, that would be 4 to the x, times v prime, which is 14x. And then we're going to do plus v, 7x squared minus 9. We'll put this in parentheses because it's more than one term and we want to stay organized. Times u prime. We'll put this in parentheses because even though it's not more than one term, it's a lot of stuff to handle. So 4 to the x times the natural log of 4. And then this time, there's not too much to make this look more pretty, so we could just leave this the way that it is. G prime is equal to 4 to the x times 14x plus 7x squared minus 9 times 4 to the x times the natural log of 4. Now remember, it may look menacing, but it wasn't all that hard for us to get to the answer. Just write down your u's and your v's and then put them together in the right order at the end. And now for our last example. K of x is equal to negative 4x to the 5th times the natural log. Find u. U this time is negative 4x to the 5th. Once we have that, then we're going to need its derivative. That would be u prime Derivative of negative 4x to the fifth is negative 20x to the fourth. And then we move on to our v's. V this time is equal to the natural log of x. Its derivative, which will become v prime, is going to equal 1 over x. And then we plug into the product rule formula. We are going to get k prime is equal to, our u was negative 4x to the fifth, times the derivative of v, which gives us 1 over x, plus our v was natural log of x, times u prime, which was negative 20x to the fourth. We can simplify this. Watch what happens when we multiply negative 4x to the fifth times 1 over x. We're dividing by x, so we get negative 4x to the fourth. We can also move our negative 20x to the fourth to the left to make this a little bit easier to read, and our final k prime is negative 4x to the fourth minus 20x to the fourth natural log of x. And so there you have it. To use the product rule, we should find our u's and v's and their derivatives, and then we just plug into u v prime plus v u prime. Sometimes you may be able to simplify your derivative or otherwise rearrange it to make it easier to read, and other times there's not much that you can do, like in the second example. Either way, the hardest part of the product rule is usually identifying that you need to use it. Remember, if you can slap a multiplication sign in between any two terms in your function, you are going to need the product rule in order to find its derivative. And that's it. I leave you with these wise words. We do not choose to do these things because they are easy, but because our teacher told us that we needed to do them. So let's at least try to do them the right way. Thank you very much, and we'll see you next time.